This is a problem where we have the combustion of propane in the presence of oxygen producing CO2 and water. This is kind of an atomic vision picture of what's going on. Here we have the reactants, the propane and oxygen goes boom. And then in that same container afterwards, there are CO2 molecules produced and water molecules produced. What is the pressure or the partial pressure of CO2 that would be produced in this reaction? Now, if we're going to know something about the products, we have to know things about the reactants. We have 10 grams of a starting material, oxygen, and assuming an infinite amount of propane. With our 10 grams of O2, how can we get the pressure of a gas? Well, this problem is done in 2 steps. The first step is taking the 10 grams of O2 and determining how many grams of CO2 could be produced. This is the first step, and things that we did a lot of problems of in the stoichiometry section, doing grams to grams type problems. Once we know the grams of CO2 that could be produced, we use gas law stuff, the new stuff, to determine, in this case, ATM. Other problems could be temperature or liters right here. So let's do the first part on the board here, and then I'll erase it and then do the second part right here. So with the first part, in a grams to grams type problem, it is solved in 4 steps. In those 4 steps, we start out with 10 grams of O2, the only thing that's given to us. We convert it to moles using the periodic table, always making sure a unit or a word cancels out. I want to make O2 cancel out, and I need to make CO2 show up because that's what I'm trying to find here, the grams of CO2. We are just doing this part in black right here. Now to get the grams of CO2, again, looking at the periodic table and just arranging things to make a unit cancel. If you don't understand where I got these numbers, 32 grams per mole and 44 grams per mole, check that out in a previous video or ask me. This scaffold right here only has the words grams and CO2. So it's going to give us this answer right here. I'm getting 8.25 grams of CO2 could be produced. So far, so if we start with 10 grams of O2, we would have 8.25 grams of CO2 produced. Now that seems like it violates conservation of mass, but remember that we have water also to produce. So the remaining 1.75 grams and all the other stuff, you got to distribute the masses. But what is the pressure that 8.25 grams of CO2 is going to exert on the sides of the container pushing out as those gas molecules are constantly moving all the time and bouncing off the sides of the container? There we use the universal gas constant, making sure we solve for pressure. Now, PV equals nRT is definitely a way to go with this. I'm not going to recommend that because the scaffold method can help you solve problems without knowing formulas. I want my final answer in the units of, so now we are doing step 2, going from grams of CO2 to find out the pressure it is exerting on the sides of the container. I want my final answer in ATM. So I'm going to start with the universal gas constant with ATMs in the numerator. So as long as I can cancel out these three remaining nuisances, I'm going to have an answer in ATM. Bang. Those are done. I didn't need to know PB equals nRT. All I needed to know was top cancels out bottom, like in math. And those words, those units, those symbols canceled out, the K's and the L's, Kelvin and the liters. Now, I got to get rid of the grams. Excuse me, I have to get rid of the moles that's in here. And I have grams right here. This is a link in the chain that I hope makes a connection here, okay? A unit that contains both grams and moles exists on the periodic table, the molecular weight. So very often in chemistry, if you have a unit to cancel and a unit you have, if you can find that middle link that contains both, that's your keystone or your missing link. The molecular weight of CO2 is 44 grams per mole off the periodic table. That gets my moles out of the way. And I have 8.25 grams. That gets my grams out of the way. And when I look back, everything is canceled except for what I want in the numerator. So this is step 2, solving for the pressure that would be exerted. This requires a calculator now. Note, I want to point this out while I have you on here. If I was asking for the liters, I would also start my scaffold out this identical way, making sure that liters is in the numerator. If the question was asking for the temperature, I would flip this and making sure that the temperature, what I'm looking for, is in the numerator. Thank you.